Hello students, welcome to the class. In this video class, I will explain you about the formation of image by the convex mirror. So in the previous class, you observed that in case of concave mirror, different positions in front of the concave mirror. Because here, in case of concave mirror, you will observe that focus and the radius of curvature are located in front of the concave mirror. But here, in case of a convex mirror, that focus and the center of curvature both are located behind the mirror. So here, as you learned in the concave mirror, that 6 positions are not possible in case of this convex mirror. So here just we know 2 points. What they are? One is pole and the distance in front of the mirror up to infinity here. We can measure the distance in front of the mirror up to longest distance, that is infinity. So there are 2 points only. One is infinity and the other is pole. So wherever you place, that means at what distance you are placing the object in front of the convex mirror above the principal axis, that is here considered as a situation that between pole and the infinity or at infinity. So here what happens if you place the object at infinity? Here if you place an object at an infinity distance in front of a convex mirror, so in case of object that placed at infinity, you won't show the object above the principal axis, only we can consider parallel beam of light rays. So here what happens when the parallel beam of light rays incidents on the convex mirror? In rules to draw the ray diagrams of a convex mirror, we learned that what is the nature or behavior of a parallel light ray after the reflection. That if a ray parallelly incident on the convex mirror surface, it seem to be emanate from the focus, that means diverges. So that ray R1. So we know the behavior. So parallel beam of light ray after reflection seem to be emanate from the focus. So in this case, that reflected light rays will not coincide or converge. They do not meet each other. So in this case, we will draw the backward rays. Remember always that backward rays will be represented with the dotted lines. So extend them. So here what you will observe, that parallel rays will be converge at a point that is focus with the backward light rays. So that image will be formed at a focus because it is the converging point with the backward light rays. So that image will be obtained at a focus. Then what are the characteristics of the image here? So you are unable to measure the image height and you are unable to decide it is erect or inverted. So it is virtual image, size is point size, obtained at a focus. So these are the characteristics of the image. So here if you place that object at a certain distance in front of a convex mirror, it may be 10 centimeters or 100 centimeters or 1 meter distance. For any distance in between them, that means here pole and the infinity, that will give you always with the same characteristics. So we will verify this with the object position at a 20 centimeter distance in front of a convex mirror. So I will put the object on the principal axis having the height exactly equal to the width of the scale. So why I am maintaining the height exactly width of the scale? To get a parallel light ray exactly. So I will draw easily a parallel light ray to the principal axis having the width of the scale. So that's why maintain object height always equal to the width of the scale. So simple, as you see here, just identify one point to maintain at 20 centimeter distance. So just from that dot, take one ray parallel to the principal axis and instant on a convex mirror at a point. Then as we learned that rules, so here parallel light ray appears to emanate from the focus. So join that point of instance and the focus with your scale. Then behind the mirror, just draw the dotted lines, and after the mirror, that means outside of the mirror, that line will be extended with a straight line, though that representing as a reflected light ray here. Now observe. So here image will not be characterized with one ray. So from the same point you have to consider one more ray, that is here R2 or R3. So what is R2? Just towards the focus it is directed, or R3 considered means it is directed towards the center. So consider anything. So here I am considering a ray directed towards the focus here. So focus means you are unable to characterize the image nature. Just look at here, it will meet at the focus. So you will not get the converging point of a reflected light rays. So don't select that R2 in case of a convex mirror. So always select R1 and R3. So now I will take a R3 here, that is directed towards the center of curvature. So we know the characteristics of that light ray behavior. If it is directed towards the center of curvature, it retrace its path after the reflection. So they are converging at a point behind the mirror. So that point is here object top, because here you are selected the two rays from the top of the object. So that two rays converging point will form the image of the top of the object. Then what about the bottom of the object? So that object bottom is located on the principal axis. So image bottom also located on the principal axis. So to get that, just from the converging point of that reflected light rays, just draw a perpendicular line onto the principal axis as you see here. So this is the position of the image. So where it coincides with the principal axis, that is the bottom. So that converging point is the top of the image. So this is the height of the image. So compare that image height with the object height. So always that image height is smaller than the object height. So that image is said to be here diminished image. So with a convex mirror, always you will get a diminished image. Then what about the position of the image? So there are two known points here, pole and the focus. That image is located in between them. So that image is obtained between pole and the focus. Then what about that position of the image? That means above the principal axis or below the principal axis. That image is faced above the principal axis. So this is said to be erect image. So the characteristics of the image obtained in this situation is erect, diminished and virtual image. So for any distance, irrespective to the position of the object in front of a convex mirror, that characteristics are fixed. What they are? Always erect, diminished and virtual image will be given by the convex mirror. Due to this reason only, we are using this convex mirror as a rear view mirror for automobiles. So here if you use concave mirror, so as you learned in different cases, that image characteristics are going to be changed. That characteristics always real. Only one situation you will get a virtual image. So that's why we won't use this concave mirror as rear view mirror. So it may be clear to you. So thank you. We will meet with another class.